Good afternoon, welcome to the Homestead. We are talking about heat pumps today, in particular mini split heat pumps, and whether they are efficient at heating in the wintertime and in frigid temperatures. Let's talk about it. So we have our house on solar, and we just installed these mini split units around the house, and we abandoned our old inefficient 3-ton heat pump unit. Now, mini splits are heat pumps, but they are way more efficient than something like this. It's currently 54 degrees out here, and these are heating just perfectly. But we have a huge storm coming through, and this is a perfect opportunity. It will be 11 degrees here tomorrow morning at about 6 a.m. So over the course of the next day or so, I'm going to monitor these and show you how they're doing. So I have two brands of mini splits also. We have the Mr. Cools, and if you haven't seen the video of me installing it, click at the top of the screen. And we also have this Innovair, which is sold by Signature Solar. So I wanted to really give you a real-time, real-world example of how these things are working. So in the next hour and a half, it should drop to about 25 degrees, which is crazy. 54 to 25 in an hour and a half. And you'll have to excuse me today, I'm a little under the weather, so my voice is a little scratchy. So here we are in our main space. This unit is set at 74, it's 54 outside, and it's 71 in the room. I'll continually use this heat laser gun to check temperatures around and outside and inside during this whole process. So if I shine this up into the coils of the indoor unit, we are at 104, 106 degrees. Yeah, right around there, 104 to 106. Now this Innovair I have set at 69, and it is 69 in this room. And the coils up in here are only at about 84 degrees. I can't get a higher reading than about 84. So here I am in the girls' room, and this one is set at 72. I like to keep it a little bit warmer for them. But my thermometer is sitting at 69.78, almost 70 degrees. And this is not kicking on right now. It feels very warm in this room. I don't know why there's a little difference in the temperatures, but that's what it is. So the coils are not on in here. The interior of the unit is at 72. And then it is cold in this room. I don't have it on. This is our spare room. This is the room where I do all the seed starting, etc. My wife sews in here, and it's for guests. This one we don't keep on because it's unnecessary. So it's about 60 in here right now. And then we're out in the hallway with the old thermostat that still does have power run to it and it still registers temperature. This one's sitting at 71. We're just off the main space here. So it's still 54 out here. Let's see what kind of cold air these are taking out of the house when it's about 70 to 71 degrees inside. Oh wow, I'm getting 36 degrees. So that is really much colder than the ambient air temperature out here. 36, it's about the same for the Innovair. Usually when they talk about HVAC equipment, they will tell you what the SEER rating is, and that's great for cooling. But today we're going to talk about the HSPF, which is for heating. The HSPF is the Heating Seasonal Performance Factor, and it measures how efficient these are when they are in their heating mode. Usually between 7 and 9 is very good. These Mr. Cools are rated at a 10. And that Innovair over there is rated at a 15, which is off the charts, really. Now, of course, all those numbers that they come up with are in perfect lab conditions, and they may or may not get that same performance out here, especially when the temperatures are going to be in the teens, which is what they will be tonight. So the other measurement factor is the COP, or coefficient of performance. And that basically is the measurement of the ratio of energy you put into something to what you get out of it. So let's say it's propane or kerosene or natural gas. That has a COP of only 1, I believe. This Innovair claims to have a COP of 14.75. So however much energy you put into it, that little bit of electricity, you're getting out 14.75 times more in heat energy into your house. Again, that's perfect lab performance tests, but hey, that's pretty good. For the Mr. Cools, I could not find the COP numbers on them. They may exist, but I couldn't find them. Okay, friends, we are outside. It is 3:45 p.m. and the temperature has dropped 30 degrees in just a few hours. So let's check what we've got going on with our heat pumps out here. Now, they've been defrosting a lot. So I've got a reading of 8.2 degrees. from that fan coming out of there. That's insane. And it's about 21 degrees out here right now, give or take. 6 degrees from this one. Let's check the one on the other side of the house. Now it's holding relatively the same temperature inside the house. It's about 69 degrees in the entire house per that old thermostat that I have on the wall in the hallway. It could be warmer in certain locations. Obviously in the bedrooms when there's an enclosed space, that is warmer. I have kicked the temperature up on the units by just a couple of degrees. So the one in the living room I think is at 75. The one in the bedroom is 73 in the girls' bedroom, and the one in my room is 70. Yeah, this one is registering anywhere between 7.5 to 8. Actually, it dipped down to 5 right there. 4, 2, 1. Oh my goodness. 1.6 degrees Fahrenheit. I haven't been used to temperatures like that since I lived in Michigan. Down here in Texas, this is quite unusual. So I will do another update as to how they're all working tomorrow morning when the temperature out here is going to be about 11 to 12. And of course, everything is in Fahrenheit. Now, a big thing that is a factor for all of you and for me is the insulation in your home. This house is 42 years old. It only has 2x4 walls with R13 in the walls. There's a blown-in insulation, blown-in fiberglass, or bibs as they call it, and it is compacted now in the attic. It doesn't have as much air just from dust in there in the attic, kind of settling down on it, and over time it is compacted. So I do have to add insulation to that. That's going to make a huge difference. Now, 2 other videos I want you to check out. One is the design I did for our off-grid energy efficient home. This is not it. We never built it. As you know, I'm an architect and I designed that one. So go check that one out for strategies to keep things incredibly energy efficient and hyper insulated. Sorry, I don't have a fancy screen sharing app on my phone, but this is the program. This is the Emporia Energy program. So the living room AC is pulling a kilowatt. The master bedroom, the one right above us, you could probably hear it, is pulling almost a kilowatt. And the secondary bedroom for the heater, or the heat pump, that Mr. Cool heat pump, is pulling about 800 watts. Now, if I go to the total for the day so far, and that started at midnight last night, you can see we've used 8.6 kilowatts out of that living room heat pump, about the same here in the master bedroom. Okay friends, it's 10 degrees outside right now in East Texas, near Tyler, Texas, and this is kicking on. It's about 95 degrees up in the coils. It's set at 75. It's a little undersized for this space, and the insulation isn't great on the house, like I said. So this space right here is at 63 degrees. Still pretty great for having 10 degrees outside, and this set at 75. Here I am in the master bedroom, and this one has been set at 69. It was perfectly comfortable in here last night, and the coils are about 100 degrees, give or take. So what's so amazing about these heat pump mini splits is they can take just a few degrees of warmth out of frigid air outside and transfer it into your house. It's totally amazing. All right, friends, we're out here. This is the Mr. Cool 12K. It's 10 degrees outside right now, and we have air coming out of this Mr. Cool DIY. It's negative 11 degrees. And then the Innovair over here, which is for our master bedroom, is about negative 10. So you can see how amazing these are. They take any heat out of completely frigid air and will pump it into your house. Now, they're not going to be super efficient at this temperature out here, but you can see it's keeping the house relatively warm. Okay friends, since midnight, this master bedroom heat pump mini split has used 11 kilowatts. The living room only used 8.5, and the one in the girls' room used 7.4 kilowatts. So you can see at the current time, the master bedroom one here is using 1.3, living room 1.1, the secondary bedroom only 800 watts. Okay, what's the conclusion? I love them. I cannot believe they're working this well when it is this cold outside. My old heat pump unit that's outside, the 3-ton normal forced air, I think it's a train, it could not keep up. Anything below freezing and it would not heat the house up at all. If you're interested in one of these, I have all of them linked in the video description below the video. And if you have any questions for me or any comments, please leave them for me in the comments section below. Now go click on this video right here, which shows you exactly how to install a Mr. Cool DIY mini split system. Have a beautiful, blessed day, and we will see you on the next video. Bye.